In the previous videos, we defined some terms associated with all simple machines. Now we are going to focus our attention on the lever. A lever consists of a rigid bar that is free to turn about a pivot point called the fulcrum. A typical use for a lever is to magnify an input force to be able to lift a heavier load. We will be calculating the mechanical advantage of a lever. MA equals the effort arm divided by the load arm, or the distance from the effort force to the fulcrum divided by the distance from the load force to the fulcrum. In our first example, we want to find the mechanical advantage of this lever. We see that the effort arm, or distance from the effort force to the fulcrum, is 10 inches, and the load arm, or the distance from the load force to the fulcrum, is 5 inches. To find the mechanical advantage, we take the distance from the effort force to fulcrum divided by distance from load to fulcrum. This gives us 10 divided by 5, which equals 2. This means that we can lift a load that is twice as heavy as the force we are applying with this lever. There are a couple of other relations that we can use when talking about mechanical advantage that will tell us how large the effort force or load force must be. If we know the mechanical advantage and the load force applied, we can calculate the effort force by taking the load force divided by the mechanical advantage. If we know the mechanical advantage and the effort force applied, we can calculate the load force by taking the effort force multiplied by the mechanical advantage. Here are the equation circles that we can use to help solve for load force, effort force, or mechanical advantage, depending on what we are given. Again, the load force is equal to the effort force multiplied by the mechanical advantage. We have load force on top, and effort force and mechanical advantage both on the bottom. Looking at our units in the English system, we will use the same units for force we have seen previously, which is pounds for load force and pounds for effort force. Remember, mechanical advantage doesn't have units. In the metric system, both of our forces are measured in newtons. Let's take a look at another example related to load, effort, and mechanical advantage. If a worker applies an effort force of 35 pounds, how much load can he lift using the lever in this picture? In order to figure out how much load he can lift, we first need to find the mechanical advantage. We actually found the mechanical advantage in the first example. 10 divided by 5 gives us a mechanical advantage of 2. Now, to find the load, we can use the equation circle that we saw on the last slide. So load force is equal to our effort force multiplied by mechanical advantage. We are told the effort force is 35 pounds and the mechanical advantage is 2. Multiplying, we see that the load that can be lifted is 70 pounds. In the next part, we need to calculate how much effort would it take to lift a 60-pound load using this lever. Now we need to find effort, so covering that up, we see we are left with load force divided by mechanical advantage. Our load force is equal to 60 pounds, and the mechanical advantage is still 2. Dividing, we end up with an effort force of 30 pounds. In the next video, we will look at the 3 different types of levers.